you know, I had to start the recording, but now I have. I also want to make sure you're going to the discussion boards. This is a quick way to make sure, and maybe you didn't get to make it to our time that we were here, at the regular scheduled time, but you still want to get credit for that week. So get on the discussion board. I take that in consideration for the actual role. You're participating, I look for that. So make sure you go through all the assignments, not just, pick and choose as you go along. If you're having any problems with the assignments, you're already logged in to Zooms, and so you should be very well fit to get online. I want to make sure that you are comfortable with the format. Unfortunately, we can't be face-to-face right now, but with this class, we can actually, it's all lecture, so it's a lot easier to throw this onto an online format than some of the other traditional hands-on type classes, like your brakes and suspension and your air conditioning and stuff like that, where you really need to get in and actually physically do some of the work. We are working very hard to get fall back going. Just to let you know, there is talk. I'm going to be going to, well, I shouldn't going to, I'm going to be on a kind of a webinar type thing, kind of conversation with the state chancellor's office, and they're going to be start talking about what's going to be happening up in the fall. So there's a lot of stuff going on at that point. Also, tomorrow, I sent you a little invite. There is going to be a town hall event with the Academic Senate of the Community Colleges of California, and they're looking for student participation, student voice about what's coming up in the fall, and it would be very advantageous if you were able to have time tomorrow to actually do that. So those are kind of my little announcements, and I want to make sure we stay on track. So with that being said, I want to start talking about the subject of the week. This week, we're going to be talking about batteries, and we're talking about automotive batteries, and we're going to be talking about the cranking systems, or what they call, starters, and also we'll be talking about the charging system. So they all work in balance. So let's go ahead and start off with the first one. I wanted to kind of get started, start off with our battery section. Our battery section, let me go ahead and grab that right now, and we'll kind of share that one. So on our batteries, they are a chemical electrical. So we take a chemical energy and we change it to battery voltage. It's very similar to what you have in your cell phone or your media players. There's going to be some kind of player that something that you have a battery in. So this is a kind of a little drawing of what a battery looks like if you were to actually have either X-ray vision, or if you had the ability to cut it apart. Now, I would not cut it apart, folks. Make sure you understand that what's inside that battery are these plates. So like they have these positive and negative plates, and they call them grids, plates, but they do, inside it also has an acid, and an acid will actually eat away, and they're very irritant. If you do get battery acid onto you, the best thing to do is to flush your whatever affected part, body part has got acid on it, and be prepared to throw your clothes away too. It has happened to me in the past a few times, and it's just an abrupt thing. It's nothing I didn't go and use all safety precautions on. It's just something that actually happened. I was just very lucky that when this one battery, I had a customer come in, and the customer said, "Hey, I got this funny smell to my car. Can you check it out?" And all I did is I took and opened the hood of her car, and the battery exploded in my face. There was a sink not far away, so I just went over, staggered over there, and I started washing off my face. But luckily, I had my safety glasses on at the time, and that protected my eyes. If it would have gotten my eyes, it could have eaten away on my cornea, and then I would probably would have been blind. It did destroy my clothes. And even though I took my shirt off and I would rinse it through the sink, the next day when it was dried, it actually started, it had holes in my shirt from the actual battery acid. So it does, it can happen. I'm just pointing out a little bit of safety. So always, 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 if you're around underneath the vehicle, underneath the car, you want to make sure you have your safety glasses on, you know, hood up, make sure the safety glasses are on. It should be a common practice, and when you get into the classes as you go along, you're going to want to make sure that you're in the lab, you're going to have your safety glasses on and all your PPEs, which are protective personal equipment, and you want to make sure you have them on. Right now, we have an extra safety equipment, and this will be will be incorporated when the labs, you know, start up in the fall. You'll be required to actually wear a mask too. Anyway, this is what one of the grids. This is, you know, positive and negative grids actually have this kind of form. There are holes in between here, but these are going to be coated with a lead dioxide or a different chemicals that actually will help produce that, will cause that chemical reaction to cause voltage. They are folded into you know, negative and positive, but they have separators in between. Now, this is what can happen, and it may have happened when that battery blew up in my face. Actually, the separator may have degraded, and when the two of the positive and negative plate touched, they actually cause an arc, possibly, or they could have actually caused a start of a battery meltdown, which actually could cause a fire or an explosion. One of the things that this is, you know, not like this type of battery, but Tesla uses a lithium type battery, and one of the compositions of it is very prone, if it's not managed properly, which Tesla spends a lot of money in their battery management software and systems, and it can cause fire and possible explosion. So just let you know that this is a possibility. How many batteries do you hear about blowing up? Not very many. How many Teslas have you actually, of all the Teslas that are out there, actually caught fire? Not that many, but still it's something to be aware of. This is, if you're, again, this is somebody took and cut this battery open, and these are actually plates with the actual separators inside of it. So each one of these plates, okay, well, these, well, I should say cells. So these sections are considered cells. And each one of these sections are actually considered, and I just had my, I apologize for that, but I just had my camera go out, but you should still be able to see the actual cutaway of the battery. So that's going to tell me right now my camera is going to be down for a little bit, and I apologize for that. But each one of these cells or these divisions here are considered, they are you know, they actually produce 2.1 volts. So when you say a 12-volt battery, actually the 12-volt battery on the shelf, fully charged, is about 12.6 volts. So we have 6 cells with 2.1 volts per cell. And this is that chemical reaction going on that causes that voltage. So we have what they call it a lead acid battery, and if it's fully charged, it will produce that 12.6 volts of actually potential. Remember from last week, we talked about electricity, and we talked a little bit about Ohm's law. This is all related. And here is actually, we're charging it back up, and we're causing it to go back. So if you go into a discharge state, you'll notice all of the chemical changes back over. and it changes to the point where we degrade to where this acid is almost water. How we used to check batteries, batteries now are sealed and they're called maintenance-free batteries, and we do not have a access to the actual acid inside, so we can't check specific gravity. If you've ever had a saltwater fish tank, you know what I'm talking about. And in the saltwater world, it is how much salt density is there in that water, and this is pretty much the same. It's what kind of density of the battery acid to the amount of water and how much it does, and it goes by the chemical reaction causes it to discharge and turn into water, and then we charge it back up to put it back into that original state. On some of the General Motors products, they had an actual battery eye, as they called it, and this little indicator would actually show a green dot when the battery was actually fully charged, which means that specific gravity was dense enough to allow that little bulb, that little green bulb to actually float. And you would see that green eye, and you say, okay, it's fully charged. But the only thing it would tell you is that whatever cell that was attached to. If you remember back, they had 6 cells, and this would be in one of the cells. The other cells could still be crippled. So this is not a real great test. It's just a kind of a basic test that they had on some of the General Motors batteries. If it went dark, and you had a black eye there, it would actually have and be below 65%. And if it went clear, you knew there was low on electrolyte. In other words, the actual battery acid inside would be way too low for it actually to measure anything. And in possibilities, because these were maintenance-free batteries, you would have had a inside the battery case, maybe a pinhole or some kind of leakage from that actual battery. And this is the specific gravity of the actual cells. And if we added them all up again, 12.6, well, actually 1.265, it would be the specific gravity, fully charged, and that would be if all the cells were equal, you would have a 12.6 volt battery inside of it. And then it really degrades very quickly on the actual voltage. As we go down just a 0.2, we actually have a 75%, and we get down to just a 12 volts. You'd think, oh, it's got to be down to 6 volts. No, actually, that fully charged battery is really degraded when we start going down. Here actually is what the new, well, I shouldn't say new, they've been around for quite a long time. Instead of having that traditional floating acid like that, they have what they call a glass mat type batteries. These mats are very specific. They do not gas like the traditional lead acid batteries. That way we don't have a potential explosion, because each one of those cells in that actual battery, the lead acid battery, produces a hydrogen gas. And if you have flame around, that's another consideration for safety, is no smoking, no vaping, no nothing around a traditional lead acid battery, or you could actually ignite that battery. It's not very common, but it's a possibility. Glass mat, they don't gas like that, and they actually produce a voltage similar, but in a different chemical makeup. Glass mat batteries, I'll let you know, these guys are actually expensive. They're more expensive than the traditional lead acid batteries. So here, what we're doing is we're actually, in a vehicle. This is actually a hybrid vehicle. We still have a traditional battery for the accessories. The hybrid batteries are traditionally either a nickel hydride, or they may be a lithium type battery. depending on which makeup you have. The hybrid battery packs are going to be somewhere around 100, 120 volts, maybe up to 300, depending how many cells they pack into it. And whereas a regular traditional battery for your non-hybrid vehicle are going to be in the 12 volt range. So anyways, this is just showing you where the accessory batteries, they call it, or the auxiliary batteries, sometimes they call it. This is what powers up and maintains your actually 12 volt electronics inside the car, like your radio and your stereo, I should say your stereo, your air conditioning, your exterior lights, interior lights, all of the basic stuff was going to be actually run off this actually battery itself. So here is another one, and this is, I point this out. This is some basic stuff that we can do, and don't really need to have a mechanic in place, but this is stuff that the mechanics would actually check too. And the batteries should be very secure inside the battery box. If they're not secure, they bounce around, and then internally the cells can actually separate. There can be some arcing going on, and there's a possibility again that they could actually explode. But this is a battery hold down. If you look over here, there's an actual bolt right here, and this little arm right here, and it's got another stud with a bolt on the end of it, and this actually, a nut on the end of it, and this actually holds and puts pressure on, a slight pressure on the actual battery itself, and keeps it in the little battery box. There's a little tray underneath here in case there's any kind of leakage going on. It's supposed to collect it and not allow it to actually leak onto the frame of the car, because that could potentially cause etching in the frame components too. And I've seen it happen, so just kind of be careful on that. All right, let's close that guy down. All right, so here's a little venting tube off of the battery, and instead of venting straight up into the engine compartment, and we normally have these in some applications of vehicles, some of your Cadillacs and some of your other applications, they'll have it either in the trunk of the car where you want to have some kind of ventilation going on, or else it can actually get into the actual passenger compartment. Or it'll be under the seat, the passenger seat. And this is one, or even in some of your minivans, we'll have it inside the actual vehicle itself, sometimes right behind the passenger seat in the actual minivan. So you want to have some ventilation to keep it actually from gassing inside the vehicle. So this will actually be routed to the outside. We do, well, I should say the batteries are rated by cranking amps. So that CA is cranking amps, and that's a special specification that batteries are rated at. Usually, in not always, it could be the chemicals inside. It also could be the plates inside. So here's 1,000 amp cranking amperature on this actually particular battery. Does that make better for every other battery, for every car? No, you really only need the cranking amps for your car. So this one actually has 1,000, but my vehicle might only require 550. I don't really need to go up to 1,000, but it is nice to have that little extra push. Now, with that being said, you can probably save some money by having a battery with less cranking, but you want to, that's a fine line. You don't want to have too little. So say for instance, mine does need to have 550 cranking amps, and I put a 325 in it. I'm going to be short about 225 cranking amps. And if I have a very cold day or very hot day, that might hurt my ability to start over that car. So pay attention to specifications of the vehicle to make sure you get it right. All right, and that is on batteries. It's kind of an overview of batteries. I don't want to, when you get into your electrical classes and like that, they're going to start talking about batteries a little bit deeper, and that will give you more insight of how the battery plays in part in that triangle of batteries, starters, and alternators. So the next thing, are there any questions before I go any farther, folks? I just want to make sure. There's different types of batteries out there. You've got everything from your AutoZones to your Cragans, and they have their own brands. I just want to let you know that the batteries construction is pretty much similar. At one time, there was only 3 companies that actually made batteries. There are a few more now, but they're all, pretty good batteries. I would prefer that you stay with a known good battery. Batteries will last probably, because they'll say on the battery, so well, it's a 72-month battery or a 60-month battery, and that, is yes if it's well maintained. If you have a battery that isn't maintained, say you just don't never take and service it, you don't check the connections on it, make sure they're clean, that battery can degrade a lot quicker. And you'll notice it, like sitting overnight, all of a sudden the next day you have to have it jump started. And after a while, you start getting that gassing going on. And again, you're going to have some problems with that. So just kind of give you a heads up on battery. Like I say, buy a good quality battery. Also make sure you maintain it, and that's keeping it clean, and also cleaning the terminals. And then the next thing we're going to be we're going to be coming up to, I shouldn't say the next thing, we're actually want to start talking about cranking systems. And on your cranking systems, it's going to be what gets that vehicle started. All right, so without further ado, why don't we go ahead and jump into that one. We'll start talking about our cranking system. Now, our cranking system, we have to have a good battery for this to work properly. That's why I started off with the battery. So if the battery's in good shape, and it actually will give enough available voltage and current to get that starter to spin. Now, this is very important. Again, connections are a big thing that we actually look at when we're going into the point where we want to make sure the starter works properly. If I have a good battery cable, if I have a good battery voltage, and the starter isn't good, that's going to crank over the vehicle when I need to. It all starts off with the battery. It goes through a set of fuses, and it goes through some wiring, and it comes down to the starter switch, where either a push button, or you may have a cranking, or you turn a key type switch. This will get the vehicle into the cranking mode. And then it goes from that to that actual cable right here. This guy right here, this cable is the voltage from that actual battery. If that is not in good shape, you can actually have starting problems too. And it goes through this little solenoid affair. This device is what kind of makes the starter engage, and it bridges over to this section right here, and it powers up that starter. Now, there's a lot of current going through. It's not like the amount that it, to do a light bulb. It's a lot more. You may have an amperage of current going through a bulb, where this could have up to 100 to 200 amps going into him. So that battery, remember I said cranking amps earlier, this is why we need an extra supply of current in our battery to actually allow it to spin this guy over. When he comes through and he's connected and he's working properly, he probably doesn't have that full 100 to 200. It might have somewhere 120 to 80 amps spinning him around. But this is something that we actually look at when we're testing our vehicles. All right, let me get that pin out of the way. All right, so here is that key assembly. This is where, this is an old traditional turnkey type system where you would turn the key to get this particular vehicle to start up. Your battery currents and all are coming up to here, and it causing that to actually engage that electrical switch. This is a little diagram of what it has to go through. I kind of give you a semi overview of it, and here's where it all started. Remember I said it started with this guy right here, Mr. Battery. He has to have enough voltage and current to make that happen, and then it goes through that cable, goes through an actual ignition switch, so it comes across here, and then it has to go through another thing. We want to make sure the car's not in gear. We may have, excuse me, we may have a clutch switch if we have a manual system where it has to have the clutch pedal pushed in for it to disengage that engage that connection. Or you may have on a automatic where it has to be in park for it actually to be able to crank over. If it says good for me, it goes through this terminal S terminal, which is the switch terminal, and it allows it to crank over. All a matter of safety. So this is that main big pole I just showed you a minute ago. So we got power coming down here, straight down to him all the time, and then we have that cranking part coming onto the other side. All right, so instead of the old traditional crank key type, we actually have a starter button here. Now this is nothing new. It's been around for quite a few years now, but now with a transponder in your key fob that is attached to your keys, you don't have to take your keys out of your pocket or your purse or whatever and actually put it in the ignition turnkey type and crank it over that way. All we need to do is walk up. Some cars will actually unlock the doors as you walk up, and then you step inside, push that button, your car starts up. If everything's good, like you're not in drive or anything like that. Here's a key fob or ticker 1. These are matched to that actual key switch. And this one actually has all kinds of functions like locking and unlocking the vehicle, opening the hatch. And maybe we're alone at night and somebody's following you or trying to attack you or something. You can actually sit off this alarm button. Your actual car will actually start honking the horn. Then this is the basic way an actual a starter works. It actually works on the principles of magnetism. If you've ever played with a magnet, you take the magnet, you put it up against a metal or surface, it'll stick. Now, if you take that magnet and another magnet and you put two similar poles close together, it will want to repel itself. It'll actually want to push itself away. You get a strong enough magnet, it pushes harder. And this is kind of the principle we use in starters. We take a device and put a set of poles with an actual armature, and then that armature will actually allow it to have positive or negative poles, and that will cause it to push and pull, push and pull. So you put enough of them along, they will actually cause it to go pretty fast when energized. See, there's that magnetic field I was talking about just a second ago. And then they just put a simplified setup here, and you'll notice this wants to rotate, cause a motion to go because those poles. And here is the actual armature I was talking about a second ago. We got it down inside, and this guy wants to cause it to push and pull all the way around. So it's going to start spinning it around. This is a pole piece off of it, or a field winding off of the starter itself, and this is what causes that magnetism to grow. And this is just a symbol of what it looks like on a wiring diagram, which you'll get more into your electrical classes also. And another setup here, a different type with an S shunt on it. And then we have a little bit of a different one. Again, this is going to be a lot more involved in this when it comes to your electrical classes. This is what a starter, a gear reduction type starter looks like. We actually have a starter solenoid, which actually does a lot of the work. There's a starter drive on the other side it didn't really show you a picture of, and that gear connects with the a flywheel of your car, allow it to actually spin it around. This will energize it, allow it to jump out, and then the starter motor will engage. And here is if I were taking a starter apart, that armature would be down inside here, and these field coils that would actually cause that electrical current, that the magnetism to grow and spin that armature around. Here's an armature, apart. Here this has a bunch of electrical wiring going to it, and which will actually by the pole piece shoes, it'll actually cause it to actually spin. Each one of these has a north and south pole on them, and it tends to want them to either pull towards or push across, push away, I should say. And this is actually how they loop it all together on the commutator. This is the inside. This is the heart. These are the field windings on the outside. Some of them are used a permanent magnet. Some of them actually use an solid energized type field windings type thing. So here's my solenoid. Here's that piece that pushed this gear assembly out to my flywheel of my car and actually cause it to spin. The actual crank, starts off with the flywheel, and which is actually attached to my crankshaft, and my crankshaft moves that pistons up and down. This is what happens when one of the magnets, this is one of the ways even I was taught when I was very, very young. If you had a car that didn't start, it went click. You took a hammer to the side, and I'm going to go back to the picture in just a sec, a previous picture for a second here. And this case, this black case right here around it, you would take a hammer and tap it. They say, oh, the actual armature is stuck, and if you tap it with a hammer, and it will actually start spinning again. Well, the problem with that is they can dislodge these actual pole pieces and cause damage. Now, this is what happens because this one actually has a permanent magnet type system on it, and actually somebody hit it really hard, and it actually damaged the whole magnet set inside. So it didn't fix it, it made a worse situation going on. This is a gear reduction type starter that has the gear assembly, and it actually causes it to spin with more torque and faster. This is the starter drive. Some old timers used to call them the Bendix. This had a one-way rotation. If it tried to kick back the other way, it would actually shear this whole internal piece here and damage it. And this is the mesh. Here's the flywheel I was talking about just a second ago. Here is that pinion gear of the starter that actually takes and puts a lot of torque out, and it starts causing this flywheel to turn. And yeah, there we go. And again, another little picture of how this would actually operate all together. So I got my ignition switch, which we still have over out here on my battery, and all my safety switches, like my neutral safety switch here also. And that's what it looks like if you were to take a little starter apart, in your palm type thing. Some of the starters are that small, believe it or not. So this one is a Buick auto stop system. Lets the driver know when the engine is stopped. Because you have some vehicles that you come up to stop sign, that are not a full strong hybrid, that actually do use the gasoline motor, and you only use the hybrid side or the battery assist when it's actually going down the road. So when you come up to a stop sign, it will shut down the gasoline motor, and it will put it into this auto stop mode. Here's a cutaway of a starter, again, showing the pinioning and all of it put together. And this is actually another auto stop type system again. This is what they consider a mild hybrid. All right. So this is all about starters, and what I'm going to do is kind of jump right over with your cranking system, and I'm going to jump right over to the next little section, and this has to do with alternators. Now, like I said, this is like kind of a all-together type starter alternator, and battery starters and alternators kind of support each other is what I'm trying to get at. So this one here, let's see, let me grab it. This is cranking. Yeah, I think it's, oh, and we should be coming up right now with the, okay, this should be seeing the charging system. Okay, so what happens is the battery supplies the voltage to the starter, and then it takes a certain amount of amperage out, and we have to put that current back in, that amperage back in. And the way we do that was with a starter. I mean, a charging system, which is, you know, actually your alternator is a big component of that. Now, that charging system is set up to where it'll charge up the battery to full charge, and then it will taper itself off to a maximum voltage. The starter, it is driven on traditional cars with a belt, and they have an accessory belt that can actually wear out, it can crack, they can break. It's a matter of maintenance. You want to make sure you check it all the time. You don't want to let this guy, the belt break, especially on what they call a serpentine brake belt system, which one belt actually rotates all the different components on your vehicle. So if you had air conditioning, if you had power steering that was belt driven, if you had other components that are belt driven, one belt would be all in. If that breaks, you lose all your accessories on it. But getting back to the alternator, it's not very big, and they've gotten smaller over the years. We used the alternators, which are really DC generators, which they produce. The alternator produces an AC signal, which is changed to a DC current. Alternating current is what comes out of, like, on your light sockets in your house. It is an alternating current, which just in essence means that you have positive and negative pulses. In other words, on direct current on your battery systems, like on our cars, they have a directional one way. Alternating, they can actually fluctuate, and they're actual different, they're different passive voltage. And you'll get more into that when you get into your electrical class too. I just want to give you an oversight on that. So inside my alternator, we have parts that are, that include bearings inside. We have it looks similarly to an actual starter. Instead of, using up energy, we're going to be creating energy. And the same processes. We're going to use magnetism to actually multiply the actual current back into the battery. And this is how we do it. We spin this guy, and he actually produces instead of taking away. The housing, you've got a bearing involved, like I said before, and also there either is an internal or an external fan. We use a fan because this guy is operating almost all the time, and we want to make sure the electronics inside get cool. If you know anything, if you've ever had you had your cell phone charging for very long, and you touch the back of it, it might get warm. And this is one thing we worry about, electronics getting too warm, because they can actually get damaged, and a possibility, far possibilities that could actually explode. Well, back over in here is what they call a regulator. This is an electronic device. This regulator, it needs to be kept cool. So on the fan on the alternator, instead of pushing backwards, it actually pulls forward. That fan actually blows forward, keeps all the dust and debris out. This is usually got vented on the backside, and it's usually pretty covered up. And it first pulls that air across that voltage regulator that actually regulates the amount of current flow back into the battery, and this guy is doing all that work. We're keeping the rest of the components cool too, because anytime you put electrical voltage through a wire, it tends to heat up a little bit. Here is a overrun type clutch assembly. You'll notice the front of this looks kind of unique. After it gets up to a certain speed, it will actually kind of go into idle mode. This is that overrun type alternator pulley assembly that was on the previous slide. Here's where the belt would be laid inside. And here is the internals of this particular overrun. Again, you'll get more into this when you get into your classes as far as your electrical classes go. This is what it looks like inside. These are the pull pieces similar to what you had on your starters. It just, like I said, instead of taking away, we actually produce. So here's a cooling fan on this particular one. Sometimes the cooling fans are up front here next to the pulley. Sometimes they're way in the back, or you may even have one that has a fan on both sides trying to pull enough air across to keep all these electronics. Here's that regulator right back in here. You want to make sure it all stays nice and cool. And here is how we actually excite that actual pole pieces to go north and south and cause that magnetic field to actually start producing that active voltage. Instead of spinning, we're using that mechanical ability of that belt to spin it. Now we're going to actually take and create that current. This is one blown apart, and it's how it's in pieces. We start up with the front. It's got a bolt to it. It actually bolts up to the rotor assembly, and it comes through the case here, the front part of the case, or the frame, sometimes they call it. And then we're supported this shaft here on a bearing, and this retains that bearing in place. And then we come back to where we put the stator assembly around the rotor, and then we come to the back side where we're going to actually have this fan on this particular model. And then we go over to the regulator assembly, and then we actually have some diodes. Now, the reason they do the diodes is because, let me draw you a little something here. If you have and this is if you had had a scope out to, and a scope being an electronic device, testing piece of equipment, I've used them back in my electronic days, and also I use in automotive service nowadays. But if you were to look at a scope, which is measures voltage over time, so time of voltage being how much high the voltage would spin, and you'd watch this kind of curve assembly going on an AC signal. And this AC voltage, this is a very bad drawing, and you can't fathom it, but believe it or not, current can be, voltage can either be 0 volts, and this is going to be my 0 line, and they can be positive, and I forgot my V. Wow, I can spell, right? Volts. All right, volts. They can be positive or they can be negative. Okay, so they can be a negative current and they can be a positive current. Now, our vehicles do not like, and our batteries are positive, no, I should say they are actually direct current type, and direct current mean everything over on the positive side. So what our diodes do inside that alternator, which is right in the back here, it's actually, we cause a stopping sensation. So instead of that voltage going back and forth, going this way and going that way on that electrical current, we actually put a stop into it. And the diode will actually block any kind of traffic going the opposite direction. So what we do on an alternator diode assembly, which is 3 of them inside, will actually cause this flip-flop. We'll get rid of him and we'll flip-flop it over. We'll get rid of him and we'll flip-flop it over. So making it all positive current. So it actually will work in our actual car. These diode trios, they can have problems. They can have leakage, and this is what we test for. We want to make sure they actually create this alternator, which produces alternating current, is only pushing out the terminal with a positive direction or a positive current. And then there again, you'll get more of that as you go along in your electrical classes. We'll get more in depth about it. I'm just giving you an overview in this class. This is what that diode trio looks like. Believe it or not, these are not supposed to be serviceable, but when I used to work with my dad, you know, early in my career at my grandfather's shop, my dad and my grandfather would rebuild these alternators. And these alternators, one of the big things were well, I shouldn't say one of the big things, it's just one of the things. This diode trio would actually cause leakage. And what my dad used to do is unsolder these diodes and put new diodes in, test the other diodes, and put the alternator back together. This is, again, an inexpensive process if you have the time. Now, remember, time is money, and it might be a little more, it will be, I'm not going to say might be, it will be cheaper for you to go to a parts house and get an alternator than to actually go through the rebuilding process. If you're going through the rebuilding process, you've got a lot of specialized equipment you're going to have, and you also will have to have a great knowledge on it, and you will have to have a good part supplier too, because some of these parts is going to be very unique, and you may end up going and searching around electronic stores trying to find all it. All right, and then again, like I said before, this is how it does it. We actually energize this, put a load on it, and it actually causes this to actually spin. But we're actually creating. So instead of taking away, we're actually putting current in, and we're spinning, and then we're actually creating that voltage coming out. Current and that voltage. So here's at actual, I was talking about earlier with my great drawing, laugh, laugh, laugh. So here is actually producing that actual voltage. You can actually do a simple little test. If you have some pretty powerful magnets, take it, kind of take a piece of wire, maybe a little, 12 gauge wire, and then take your magnet, you'll need a voltmeter, and you can put a voltmeter across the actual wire and take your magnet and kind of just buzz it around the outside of right close to that wire, and you can actually watch your voltage increase. Simple principle. And what they do to make alternator more powerful is they put more winding inside, and it causes more, we multiply the current. And this is one of the windings. You'll get more into it when you get into your actually classes and all. Again, another one showing you the different, this is should be a Y winding type system on this particular one by looking at it. And then you have your delta wound type alternators. It's just how they actually do the actual interior winding on them. And this is what a stator simply looks like. That's what's on the outside, and then you have your rotor inside here. And this is just telling how the voltage regulator, it's got a threshold. It gets up to a certain point, it regulates down, and your alternator will just keep on charging, baby. Just keep. And that is a problem we have in the field once in a while. If you get a car that all it does, you're changing light bulb, headlights and interior lights all the time, you want to start checking that charging system. You may be overcharging, and it's actually popping those bulbs. You usually have, especially on your lead acid batteries, you have a very much of a sulfur smell to them. This is a electronic, and they're all electronic nowadays, regulator that's inside the alternator. It's all a little circuit board. This is what regulates it out and keeps it to that 13.8 to 14.4 voltage pattern. Some of them go a little bit higher. Some of the products actually go up to 15 volts. And this is showing that regulator all in all the alternator circuit together. So this is a wiring diagram showing everything together, and it even goes into the indicator light. And if you're lucky, you have a gauge that actually reads out a voltage too. Not very common anymore. Some of them, they actually had coolant hoses going through them to keep that alternator cool. And in here I have an actual sensor. A portion of the vehicles that are out there right now are actually controlled by the computer of the car. Instead of having a regulator and and allowing it to regulate the charge from the regulator. They'll actually have the computer doing a lot of it. And one of the things about battery principle, they charge at certain rates at different temperatures. And with a battery sensor attached to it, and we're monitoring the battery voltage anyways, we can actually regulate them out how much current can go into that battery. And we can force it really hard when it's cold, and we can kind of taper it back off when the battery is warm. And that makes it the life of the battery last longer also. Here I actually have a pattern of the actual charging, and this is again where you'll get more of it into it when you get into your electrical classes. And this kind of shows you a little bit what kind of duty cycle we would be charging that. All right, and that kind of covers all of that, folks. I do want to open it up for questions. Anybody have anything they want to clarify or I'm not sure of, and I will be more than happy to answer any questions beyond that. If not, you do have assignments up right now on Canvas, and there's due dates by this Saturday by 11:59. Remember to get into the discussion group. I made it fairly simple. All you have to go in and is talk a little bit about, and this week's topic is about batteries and what you feel is the best battery for your car or a car. And you can give me kind of your opinion on a little bit of what we talked about today, a little bit of maybe you have some prior experience in batteries on cars and like that too. So if you have no questions, I'll sit here for a few minutes and I'll wait up. If not, I did put up my office hours for today and for the rest of the week. One thing I am excited about is with Zoom, they do allow you to schedule meetings, and then if you schedule the meeting, it is the same, excuse me, it is the same invite link that we have for all the classes the rest of the semester. So every Monday, we will be meeting with that same link. I don't have to send you another link each time, but I will send this link again. And it will continue to be the same, almost like the same room all the time. So like I said, I'll continue to send the links, but you can just refer back to the announcement page, and it will give you the link for every class for the rest of the semester. All right. If there's no questions, like I said, I'll sit back for a few minutes, and if there are no questions, you are dismissed and you are free to go. All right. I'm going to sit here and try to figure out what happened to my camera too. And I will talk at you all a little bit later.
Bye, Mr. Rudd.
Yes, talk to me. Is that a question? All right. All right. Thank you.
Bye, Mr. Rudd.
Bye.
All right. Take care of yourself now.
You too.